You're welcome to my YouTube channel. In today's video, I'll be sharing with you a problem in material balancing, and this problem has to do with mixing two items, two products together to get a particular mixture. And in this case, we have two products like pork and backfat that are to be mixed together to get a mixture. And pork has 15% protein, 20% fat, 63% water. And backfat has 15% water, 80% fat, and 30% protein. Now they are to be mixed together to produce a mixture containing 25% fat of 100 kg. So now the question in complex says how much amount of pork that is of 15% protein, 20% fat, 63% water should be mixed with back fat containing 15% water, 80% fat, and 30% protein to make 100 kg of a mixture containing 25% fat. Now in material balancing, when we're talking about mixing, we have the two materials. Let's say solution. Now we have the two items. Now the first one, they say that question says he had pork. Now the pork had 15% of protein, that's 20% of fat, and 63% water. Now it was mixed together with back fat. Then the back fat contains 15% water. Add 15% water. It also has 80% fat and 30% protein. Now in this case, we are talking about mixing. So now pork and the back fat with these components were mixed to produce a mixture containing 25% fat, and the amount of this mixture was 100 kg. Now the question is saying that what is the amount of pork in mass that will be mixed together with the back fat with these components to produce 100 kg of the mixture. So first what we do is we designate pork with P, backfat with B, and then the mixture with M. Alright, so now the next thing we will do is we write our mass balance equation. Mass balance equation. And so from the way the question says, since it's mixing, that means we had pork mixed, that is plus the back fat is equal to the mixture, which is M. And so the mass of the pork we don't know, so it is P, plus the mass of the back fat we don't know, and it's equal to the mass of the mass of the mixture is 100 kg. Is 100 kg. And so we now call this equation 1. Now the next thing we're going to do is we're going to form a component mass balance equation. So we say component mass balance equation. Now in component mass balance equation, we have their components, which are the protein, the fats, and the water. So these were their what? Their components. But one component is common in all, and that is the fat. Pork had 20% fat. Back fat had 80% fat, and then the mixture had 25% fat. So what we'll do is we make use of those common components of these of these fats. So we had for pork, we had that 20% of the pork plus 80% fat of back was equal to 25% of the mixture. And so having 25% of the mixture, now the amount of pork we don't know, but the amount of the mixture is 100. And so we now have what? 20 over 100 times P plus 80 percent 80% of times B is equal to 25 over 100 times, now the mass of M is what? 100 what? Kg. So it's 100. And so what do we do next? Since we have 100 dividing here, dividing P and dividing here, and it is common, cancel it out. And so we now have 20 times P, that is 20P, plus 80 times B, that is what? 80B is equal to 25 times 100, that is 2500. So we'll call this our equation what? 2. Alright, so we have successfully formed our mass balance equation, that is equation 1, and then our component mass balance equation, that is our equation 2. And so the next thing we are going to do is we are going to use these two equations in question to calculate for the amount of the backfat that was mixed with the pulp to produce 100 kg of the mixture. Alright, so we had 80, we had the equation 1 to be, P plus B equal to 100 kg, was the equation 1. Then we had 20P plus 80B equal to 2500 to be our equation 2. So what we are going to do is, since we have two equations in question, then we are going to solve them simultaneously. So we say solving simultaneously. So we say from the principles of simultaneous equation, we say that from equation 1 or equation 2, anyone, you make one of these parameters, either the the pulp or the backfat, subject to the formula. So in this case, we are using equation 1. So we have P plus B equal to 100 kg. And so B is equal to 100 kg minus B. This will now be our equation 3. So now the next thing we'll do is we're going to substitute this our equation 3 for the value of B in equation 2. So you say substitute B into equation 2. Alright, so that will now be 20P plus 80B is equal to 2500, and so P now is this. So we have 20 place of P, that is 100, minus B, then plus 80B equal to 2500. Alright, so now we had, so 20 times 100, we have 2000. 20 times minus B, we have minus 20B, and plus 80B equal to 2500. Alright, so we had 20B plus 80B is equal to 2500. This will come over this way, so it will be minus 200. Alright, so minus 20B plus 80B, that will give us 60 B, and that is equal to 2500 minus 200. That will give us 500. Alright, so we'll now say our B now is equal to 500 divided by 60, and that will give us 8.33 kg. So now 8.33 kg is the amount of back fat. That is the amount of back fat. And so the next thing we are going to calculate is the amount of the pork. And since we've gotten the amount of back fat, what we do next is substitute this value we have had for the back into equation 3 for the back, then subtract it from 100 to get the amount for pork. So we say substitute B into equation what? 3. And that is equation 3 is B plus B is equal to sorry equation 3 is P equal to 100 kg minus B, and P is equal to 100 kg minus what? All of B is what? 8.33 kg. And so P is now equal to 100 minus 8.33. That should give us what? 91.67 kg. 91.67 what? Kg. So we now say therefore the amount of pork and back fat mixed to produce 100 kg of the mixture is 91.67 kg and 8.33 kg respectively. And so that's in a simple way we've calculated the amount of pork that should be mixed with back fat to produce 100 kg of the mixture containing 25% fat. And then in the question, using it simultaneously, after forming the two equations, we now got component mass balance equation and the mass balance equation, and then we have solved for the amount of back fat, and this is the amount of pork. So successfully we have calculated, and this is Danny Food Tech. Consider subscribing to our videos. By subscribing, you press the subscription button and then turn on the notification bell so that we notify you for our next video that has a simplified way of calculating other problems in food engineering. Also, we bring lectures on microbiology, food analysis, and food biochemistry. And we simplify these lectures for students in food science and technology and microbiology. Thank you for being with us through our video. See you in our next video. Thank you and God bless.